Hi Year 9. This is our third lesson for the topic of numbers of any magnitude. In this lesson we're going to look at error in measurement. So far in this topic we have learnt about significant figures, we've revised units of measurement, and we've looked at measurement conversions. In our first video we looked at this question. Rectangular room has dimensions 4.449 metres by 9.823 metres. And we worked out the area of the room just by multiplying. And because we had 4 significant figures in both of these measurements, we did 4 significant figures in the answer. And then we looked at what happened if we rounded both of these dimensions to 2 significant figures first. So this would become 4.4 and this one becomes 9.8. And we worked out the area. And instead of having 43.12, we had to use 2 significant figures for the answer, so we got 43 metres squared. And we could see that a certain amount of error crept in because of our rounding. So the problem with rounding is that it leads to error, and maybe it will be an issue and maybe it won't. But in this particular example, if we were ordering carpet, we would run out. So when we round measurements to the nearest unit, we create error. For example, if my height is 157.3 centimetres and I round it to the nearest centimetre, that's 157 centimetres, I am 0.3 of a centimetre out. So any measurement is only accurate to 1/2 of its smallest unit. Or we could say that the maximum error of any measurement is equal to plus or minus 1/2 of its smallest unit. Now what does this mean, the smallest unit? Here's an example. What do you think is the smallest unit on this ruler? If we have a look here, we've got centimetres, and in between centimetres we've got millimetres. And the smallest unit that I can see is 1 millimetre. The maximum error is going to be plus or minus 1/2 of that. So we could do plus or minus 1/2 a millimetre or plus or minus 0.5 millimetres. Here's another couple of examples. What is the maximum error for this device? So this one's in kilograms. The smallest unit that I can see there is 1 kilogram. So the maximum error is going to be plus or minus 1/2 a kilogram. And this one's slightly different. You can see here 50 mils and then 100 mils. So we work out what each of those little lines are. They must be 5 mils each. The smallest unit is 5 mils, so maximum error is plus or minus 2.5 mils. Now these examples are slightly different. Find the maximum error of the following measurements. 16.2 centimetres rounded to 1 decimal place. Now it's different because we don't have a device that we can look at. There's no tape measure there that we can find what the smallest unit is. But it's kind of in the question. It's been rounded to 1 decimal place, so the smallest unit is 0.1 of a centimetre. We can't get any more accurate than that. As soon as we know the smallest unit, the rest is easy. The maximum error is plus or minus 1/2 of that. Plus or minus 1/2 of 0.1 is 0.05 centimetres. And last one, 150 litres rounded to 2 significant figures. So that's the 1 and the 5. And that's really the same as rounding to the nearest 10. And that's our smallest unit, 10 litres. The maximum error, plus or minus 1/2 of that, plus or minus 5 litres. Now, if we're given a rounded measurement, we can actually find the range of the initial measurement. All we have to do is add and then subtract the maximum error. Here's an example. Julie measures her waist and rounds it to the nearest centimetre. If the rounded measurement is 78 centimetres, what are the upper and lower bounds of the measurement? They mean, what could it have been before it was rounded? Okay, so we need to work out the smallest unit and then the maximum error. The smallest unit is 1 centimetre. The maximum error is plus or minus 1/2 a centimetre, and that's exactly what we're going to do. We're going to subtract 1/2 a centimetre and add on 1/2 a centimetre. So subtracting 0.5 gives us a lower bound of 77.5 centimetres. Adding on 0.5 gives us an upper bound of 78.5 centimetres. So anywhere in between these two will round to 78 centimetres. Now you probably noticed something funny here. 78.5 would actually round up to 79, wouldn't it? But this is just a cutoff. Rather than write 78.499999, we just write 78.5 for ease. So subtract your error, add on your error, that will give you your range of measurement. Let's try one more. What is the range of the actual measurement if a measurement of 152.6 kilograms has been rounded to 1 decimal place? Right, the key is the smallest unit. 1 decimal place, so the smallest unit is 0.1 of a kilo. Maximum error is plus or minus a half of that. So do a half of 0.1 on your calculator, gives you plus or minus 0.05. Now subtract that from this and then add it to this, and that will give you your range. So the actual measurement could be anywhere between 152.55 kilograms, that would round up to 0.6, wouldn't it? All the way up to 152.65 kilograms. So anywhere in this range is going to round to 152.6 kilograms. Now once we've worked out the error that we've created, we can calculate the percentage error. And here's the formula. Percentage error is equal to the approximate value, take away the exact value, divided by the exact value. And there's some funny symbols here which you may or may not have come across before. These are absolute value signs, and that means ignore any negative. So if you get a negative, then just strip the negative off. And then we're going to take this fraction and multiply it by 100. So what is the percentage error if a measurement of 77.32 centimeters is rounded to 77 centimeters? So here's our formula. Now the approximate value is this 77 centimeters, the rounded value. The exact value that goes in here is 77.32 centimeters. So let's substitute it in. The first job here is to work out this numerator. 77 take 77.32 is negative 0.32, and the absolute value means strip that negative off. Now we just put this into the calculator and we end up with 0.41%. Okay, in our last lesson for this topic, we're going to look at scientific notation.